Here I have in blue y equals sine x graphed, and here in green I have y equals cosine x graphed. Looking at the sine x curve, at this point here, the slope is 0. I'm going to plot the point. This is a 0 slope, so I'm going to put 0 for my y. This is a 0 slope, so I'm putting 0 for my y. This here has a -1 slope, and I'm just graphing the slope values. Here, it's a +1. Here again, it's a +1. And what I'm seeing is all these points are falling on the y equals cosine graph. So what we have is, for y equals sine x, y prime is going to be cosine x. So here we have in green y equals cosine x, and I'm going to graph this time the slopes for cosine x. So cosine x is +1 here, and its tangent line is 0. So I'm going to graph the 0. I'm only graphing the slopes. Up here, sine x is positive, but the slope here is -1. So the slope for here is going to be down here. Then we have a slope at 0, that's up here. Then we have a slope that's going positive over here. And then again, we have one at 0. Notice that the curve is following an inverse of the slopes for the sine x curve. If I was to actually multiply sine x times -1, the graph would look like this. And the purple line is y equals minus sine x. So for y equals cosine x, the first derivative is y prime equals minus sine x. In order to find the derivative of tangent x, we're going to need to look at a few trig identities and information that we already know for derivatives. First, we understand that tangent x is equal to sine x divided by cosine x. Well, without absolutely knowing what the derivative of tangent x is, what I can do is I can find the derivative of this quotient here, since I already know the derivative of sine and cosine. So let's just review the quotient rule real quick. When we have f of x divided by g of x will equal g of x times f prime of x minus f of x times g prime of x, and that whole thing over g of x squared. So plugging in those values on the left, so if sine of x is f of x and cosine is g of x, then I have g of x, cosine x, and then f prime of x, the derivative of sine x, which is cosine x. So I have cosine x times cosine x minus, and then I have f of x, which is sine x. And then I have g prime of x, which is the derivative of cosine. We have that here, minus sine x. And that whole thing is over cosine squared x. So all of this will simplify to be, recalling from high school trigonometry, we know that cosine squared x plus sine squared x equals 1. And we also understand that 1 over cosine squared is the same as secant squared x. So for y equals tangent x, y prime equals secant squared x. Using the same methodology, I'm able to use the quotient rule to find the cotangent's derivative. So cotangent is equal to the inverse of tangent, which is now going to be cosine x divided by sine x. So to find the derivative of cotangent x, I take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and all of that over the denominator squared. Next, I multiply on top, so I get minus sine squared x minus cosine squared x. Then I factor out a -1, leaving me with sine squared x plus cosine squared x, which equals 1. So it's -1 times 1 over the denominator, which is sine squared x. Further simplifying, we get -1 over sine squared x, which is minus cosecant squared x, which is the derivative of y equals cotangent x. The final two derivatives of trig functions are for secant x is secant x tan x, And for y equals cosecant x, y prime would be negative cosecant x cotangent x. Now that we have the 6 basic derivatives of trig functions, let's use them in some practice problems. So here we have a function where there are two terms being multiplied by each other, so we're going to use the product rule. So f prime of x equals, plugging in the values, I have f of x times the derivative of the second, plus the second times the derivative of the first. Simplifying, we have, this is as far as we can go, so this is the final answer. Here we have y equals 3x squared over secant x. So we have the top times the derivative of the bottom, plus the bottom times the derivative of the top over the bottom squared. Once simplified, I notice that I can take a secant out of both of the top terms, so I'm going to factor that out. And secant goes into itself once and into secant squared x secant x times. There's your final answer. On this problem, it's actually simpler. It's just that it's to illustrate what happens when you have two different functions that are connected either by addition or subtraction. Just simply treat them as if they're two separate problems. So this is going to be 3 times, and then the derivative of cosine x is minus sine x. Minus, I bring down the 7, and the derivative of tangent x we see is secant squared x. And there's a minor simplification. I have minus 3 sine x minus 7 secant squared x. That's the final answer. So in this last example, we have negative coefficients. You again treat them as two separate problems. So I'm going to bring down the minus 3. The derivative of cotangent is negative cosecant squared x. Minus, keep the coefficient, and the derivative of cosecant x is negative cosecant x cotangent x. Well, this answer is correct. You can factor out a GCF, which is cosecant x from both terms, and it would look like this. One final note that I want to take a look at is whenever you have, see, this is sine, this is cosine. Whenever you have these cos here, this is cosecant, you're going to have a negative in your derivative.